Bartek. Wherefore art you, Bartek?
Yes. Okay.
You've ruined all our Romeo and Juliet's quotes now.
We didn't even do that one in school.
Okay. Hello everyone. Let's start. My name is Bartlomiej Plotka, and I'm here with Tom Wilkie. Tom is VP product of the Grafana and one of the initial authors of the Cortex project. And I'm a software engineer at Red Hat and one of the co-author of the Thanos project. So today we want to walk you through those two projects, Thanos and Cortex, which I would say extends Prometheus in some way, and maybe talk. We'll go through kind of trade-offs and strengths each project has from the very high level overview, and hopefully those will help you to choose what project to use if you are looking for the next long-term storage, for example, system. And at the end, we are planning to tell some exciting plans for the future. So it's pretty cool. So as the title states, two households, maybe two systems, maybe different, but alike in the same way. Awesome. So just quick catch up. Thanos was started almost 2 years ago by Fabian Reiners, who is somewhere here, maybe in this venue for sure. So if you meet him, like say hello to him. And me, it was almost 2 years ago. And then, this year we also joined the CNCF sandbox stage. On the other hand, Cortex was started year before Thanos, 3.5 years ago, and by Tom and Julius Waltz. And they joined CNCF sandbox stage as well year before Thanos. So, okay, before we move on, some questions to the audience. Who is using Thanos? Wow. Wow, I'm surprised. Okay, so I hope we have nice discussion today on the party about current, issue progress and discussions and plans for improvement. So that's pretty cool. Who is using Cortex? Yeah.
And how many of them work for the Fun Labs?
Anyway, even though like you're running a huge scale, so if you have any questions around that, like grab Tom or anyone from Grafana. Because that's exciting as well. Okay, who is using Prometheus Federation? All good Prometheus Federation. Yeah, that's good. I'm using Federation. So that's pretty exciting as well. Okay, so I'm asking because we want to share what are the goals we want to solve. What were actually the goals we wanted to solve where we're designing those both systems, and what did we want to solve essentially. So probably everyone is familiar with those, 3 dreams every Prometheus user had, any observability system actually have and want to have, right? So first of all, global view, right? So, ability to do queries and aggregations over the data from the multiple Prometheus servers. For example, you maybe want to have the memory consumption for certain service over multiple clusters, right? Or maybe average QPS of those servers across different data centers. So that's pretty important questions to be able to solve from the single query and not manually count that on different dashboards, right? Or different queries. And overall, you can do Prometheus Federation for that, and that's true. However, it has some painful points. So we need to look for another solution on that. We also need to, users want to have Prometheus to be highly available, right? One is that because, yes, monitoring is very critical, but because mainly is that when you have an outage, you don't want to have gaps in your graphs, right? So we want to really minimize the downtime of both ingestion and the query path. And last but not the least, you want to learn from the past and run some, long-term analysis on the metrics, or maybe look on the past situation that happened, and see were the metrics and the characteristic back in time. So, for example, you want to compare quickly, you have regression and you want to compare what were the resources usage on the certain situation back in time, or maybe you missed some metric analysis on certain postmortem analysis and you want to go back to that. So that's pretty important stuff. Or maybe if you want to have some, do some capacity planning, how you do that, you need to compare, maybe CPU's resource usage that was happening in the past during certain load, and you want to see the growth of it and try to predict and how to allocate that beforehand. And yes, you can still say that Prometheus local storage is just enough for this purpose, for the long-term storage retention. There are people who are running that for years, with years of the data. However, it's tricky. It's tricky to backup, perform other certain operations like resize and migrations, etc. So overall, both Thanos and Cortex was built with those in mind. So let's move to the first goal, global view. So how we can combine those data from the multiple Prometheus servers into one single PromQL evaluation. So to get an average, of the global latency, or I don't know, of the sum of the global resource consumption, or just simply count how many services I have overall in my infrastructure, right? So basic use cases. So let's look on the Thanos first. Let's say you have some vanilla Prometheus servers, and they're running each in the separate cluster. To attach Thanos, you start a sidecar component next to the Prometheus. And as a further step, you start a stateless queries services, which does the global evaluation for PromQL, which the query fanouts to the each correspondent matched Prometheus server and pulls the series from the Prometheus through the sidecar and back to the query. And this allows to finalize the query and aggregate the data over multiple sources. So Grafana now, or any other client, can have access to all of the Prometheus servers within one query. In Cortex, it's a bit different. Instead of pull, we have push, right? So you configure Prometheus to stream the data to Cortex cluster via remote write API. In this central cluster, Cortex ingests the received metrics, saves it to the disk, to the storage, of your choice, and all the queries from the client from Grafana can go to this central location and then have access to all of it because everything migrated to it. And yes, let's start to maintain just simple table comparison of those two projects for every dimension or for every feature we are talking about. And but before we go to the strengths and trade-offs, let's talk about similarities, right? Both projects, Thanos and Cortex, are using exactly the same PromQL engine implementation that Prometheus is using, the same query, exposing the same query API, and they use gRPC protocol for internal microservice communication. So the differences, the main strengths, I would say on the Thanos side, it's easy to deploy and incrementally adopt. This is because you don't need to create another cluster and maintain a write path that is scalable. On the other hand, Cortex has this powerful feature of feature characteristic is that if one of these monitoring clusters or Prometheus are down, or there is an outage, or there's network partition between you and this cluster, you can still observe the data which from the centralized Cortex cluster. So you can maybe even figure it out what caused this outage in the first place. So that's pretty powerful. Tom?
Thank you very much. I must say it's a bit surreal having you present on Cortex.
Yes, I feel very comfortable.
And now it's going to be even more surreal to hear me talk about Thanos. What does that say? Okay, multi-replica Prometheus. So we should all be pretty familiar with this. Prometheus is a single binary, and only has dependencies on its disk and on its network. So if you need to restart that machine, if you need to upgrade Prometheus, you end up with a gap in your graph. Right? It's that simple. And this is not nice. We want to get rid of those gaps. The best practices is to run a pair of Prometheuses, but Prometheus servers. Where's Bjorn? Prometheus? Yep. And but the problem is you still have these gaps depending on which one you go to, right? And they might be slightly out of sync because they might scrape at slightly different times. So what does Thanos do? Thanos, as we talked about earlier, it fans the queries out and pulls the data back from each Prometheus. So if you run two Prometheus with the Thanos sidecar in each data center, it will pull from both of them. Then at query time, it will dedupe between these two different sources of data, and it uses a really simple algorithm to figure out which one to show, and basically gives you that no gaps experience, what you want. Cortex does this differently again. We push from pairs, and then at write time to Cortex, we choose which pair to read to accept the writes from. So we effectively dedupe the data. This is actually something Callum, where's Callum gone? Yep, Callum implemented this maybe at the beginning of this year. And this means we only store one copy of that data, and then all the queries just go to that one copy. It's pretty straightforward. We use an etcd or a console to basically store consistently which one we're accepting samples from, and then we use like a simple timeout. So let's compare the two. In Thanos, it's query time. In Cortex, it's at write time. That's about it, really. They both basically give you the same solution. I wouldn't really draw any massive differences. Like, I think one really, really minute, tiny detail is like at write time, basically shortly after that data's been scraped in Cortex, we've chosen which one to write, we've chosen which one was the authoritative source, we've written it to disk, and that's never going to change. With the Thanos, because you're deduping at query time, the result you get will actually depend on which Prometheuses are available. So if both are available, it's stable, but if one's missing, you might get a slightly different result. But even then, you've got to really be paying attention to notice the difference. Thank you.
Thank you.
Was that accurate?
Yes. Cool. So let's move to the last item on our agenda: long-term storage. So how we solve the problem of storing months and years and accessing those data over time. So can you raise a hand if you would like to have your data that you are storing with the Prometheus long-term, like months or years? Would you like to have a long-term storage? It's not everyone, like 90%, but still. So yeah, I mean, it is useful. I mean, I'm sure this answer depends on on the cost of that decision, right? So that's important factor. However, still, yeah, everyone agree it is useful to have it. We're talking about capacity planning, maybe post-mortem analysis. Maybe you want to report your SLIs, right, over time and compare with SLOs, and you want to have this report, per month. And so having that ready to go just ad hoc in the ad hoc query is super useful. So how Thanos achieves that? Thanos, let's start with the Prometheus, right? Prometheus stores the data in TSDB blocks, and actually it forms all those blocks every 2 hours in just 2 hours blocks, which is called TSDB essentially block. And Thanos Sidecar, if enabled, is capable to upload synchronously those blocks to the object storage of your choice. It can be GCS, S3, Azure, and a couple of more. And thanks to that, you can set up in your centralized place store gateway, which is responsible for fetching the series or selecting the series from the object storage, maybe month or years of the worth of blocks from the object storage itself, right? Additionally, Thanos runs compaction to compact smaller blocks to bigger one, and it can be extended with downsampling of your chunks. And at this point, query on the maybe global location have both access to the fresh data from the Prometheus and the long-term storage data from the store gateway, which grabs the data directly from the object storage, which is the only dependency of Thanos at this point. For Cortex, this is again a bit different. Everything is streamed to the Cortex cluster, and during kind of the ingestion path, Cortex batches the received samples into XOR compression chunks, which are exactly the same compression format that both Prometheus and Thanos are using. It periodically flushes those chunks into the object storage as well. However, it builds the index. It has to build the index, inverted index, which is really, really similar to the TSDB index that is put into the block. However, it is flashed to the NoSQL database. Now, on the query part, again, client or Grafana dashboards are accessing those, querying the central Cortex cluster, and Cortex then are doing the lookup from the NoSQL database, so where the index is stored. And I should mention that it could be Bigtable, DynamoDB, and Cassandra. And lookup tells you what chunks you should fetch from the object storage, and that's how you satisfy the query. And this is overall how Cortex queries the long-term storage. Now, again, maybe start with similarities. At this point, we all use XOR compression chunk, Prometheus, Thanos, and Cortex, which is nice. And the main difference, I would say, comes from the trade-off of between operational cost and the performance. Now, Thanos uses object storage, so it's the only kind of dependency it has, and object storage tends to be cheaper. However, Cortex is using NoSQL databases, maybe mostly for the indexing, but still, and it can lead to the better performance. However, as you may probably know, NoSQL tends to cost more per IOPS or data storage. So this is actually the main high-level difference between those two systems. So we can simplify to those two, to this one trade-off. Now, as you can see through all those kind of comparisons, we have many overlaps, but not many overall differences. Hopefully this kind of high-level comparison helps you to kind of map in your mind where are those systems laying, and where are the trade-offs. Let's move forward to nice, exciting stuff. So, please.
Thank you, Bartek. So, what are we on to next? Future. So, you may not know, but Bartek also lives in London, as do I, and we like to get together and plot and scheme occasionally. And so we've been wanting to kind of work together a lot for a while now, and we've come up with a couple of projects that we've started. So I just want to give you a little bit of an insight into how Cortex and Thanos communities can work together. So the first one, this is pretty straightforward. We have a component in the Cortex architecture called the query front end. So the query front end's job is to take in queries. It will slice them up so that you can parallel process individual days worth of data, and then it will cache the results of some of that data. And there's a lot of detail in there about how it caches it and how it aligns it with steps and how it recombines the results and how it makes sure you get fresh data. But if you want those details, there's a blog post. There's also a talk at the meetup that Bartek organizes in London, actually. One of the pieces of work we've done recently is make it so the Cortex query front end can talk to any Prometheus compatible API. So you can put it in front of Prometheus, you can put it in front of Thanos, and you can get all the benefits of caching and of parallelization that you do with Cortex. And this, it's very sensitive to the kind of query you run, but I would argue for almost every type of query, this will make it faster. And especially for queries that hit the cache, for queries that go over very long time ranges, this can make things significantly faster. And it's also worth saying this is not an original idea, right? Like Trickster, the Comcast projects, did the caching. The only reason we ended up building our own one in Cortex was because the Trickster wasn't particularly embeddable. But I understand they've actually improved that now as well. So that's the first point. You can put Cortex query front end in front of Thanos now, which I think is kind of cool. Do you know anyone? We do that at Grafana Labs.
We do as well.
Yeah, awesome. So you should do this. It's really easy. The instructions in that blog post.
Yeah, but definitely we should document it more.
I wrote a whole blog post. Anyway, okay, right, the next one.
Let's go.
So this one's really cool, actually. So Bartek talked about how object stores are cheaper than NoSQL stores. This is not something we shy away from. And something we've always wanted to do is adopt a lot of the Thanos style of flushing blocks and querying blocks in object stores in Cortex. So I can't actually claim credit for this because this was actually done by Thor at DigitalOcean. They put a PR in that made this work, and it's still kind of prototype. We've merged it, but only enable it if you're very kind of experimental. But it works, and you can now have Cortex build chunks and flush them to an object store. I believe right now we actually only work with AWS, but that's just because of the way we've embedded the config. And it should eventually work. Is Marco here?
It works with GCS now.
It works with GCS. Okay, we've merged that PR. But yeah, so you can have this flushing blocks to GCS, and we can query those blocks off of GCS, and you can operate Cortex in a very similar way to how you operate Thanos. And in fact, we've just used the Thanos code to do this. We've just rendered the code and integrated it in the right way. So this is kind of interesting. I think this is kind of a bit strange. And one of the things I think I'm particularly keen on here is, a lot of the improvements we can make in Cortex, we focus on very large scale. The clusters at Grafana Labs are getting pretty big now, and we're always focused on query performance. The talk I gave earlier about, the talk I gave at the meetup was all about caching and parallelization. And actually, I'm hoping maybe if we get time to do a little lightning talk with something cool we're doing with query performance at the moment. And I'm hoping we can start bringing some of that to Thanos as well, like some of the very large scale we run at, and some of the query performance and caching and so on to the Thanos code base. Yeah, if you want to check out Thor's PR, it's linked there. Otherwise, I think we've got 5 minutes for questions. Thank you very much.
So we've up to 15 minutes for questions.
What?
Yeah. Well, the previous one finished 10 minutes
early.
early.
More lightning talks.
Well, I can also do that. I will make a brief plug while you're thinking of your deep and detailed questions. That there is the board out there. Now, in principle, we already have enough talks for today and tomorrow, depending on how fast things go, but you can still put things down. We might end up doing more tomorrow. Also, apparently, the not safe for work spam has migrated to #PromCon 2019. So, yeah, if you don't want to see it and it's not pretty, don't look at that. I've personally reported them all. I don't know. Anyway, first question.
On the far back.
Oh.
Can we just make sure the questions come from the other side now next?
You tried to do this last year to me.
No, the far back, yeah. Seriously.
In
Oh, he's got
terms
mine.
of querying, for Thanos, as it's actually querying Prometheus, does that mean that you could write a query that crashes your entire estate? Because it
Yes.
counts and memories everything. Whereas that's not possible for.
I mean, we've definitely had queries of death in Cortex, yeah.
But it wouldn't actually crash the.
It wouldn't
source.
crash the Prometheus because they're isolated via remote write, but you could crash the central Cortex cluster. I wouldn't say quite easily. I mean, we haven't had one for over a year now, but I'm just trying to think. The last one was probably over a year ago now. But yeah, it's possible to take down a Cortex cluster with a.
So is that potentially an advantage on the Cortex side that it's that slightly more decoupled that you might not break anything?
Yeah, definitely. Like ingestion is decoupled with the querying on the Cortex side. However, nowadays, essentially with the new remote read that we have, it's harder to kill Prometheus itself because you have you stream those series and you can have like a timeout. So yeah, it's pretty hard to actually kill it with the read path at this point. But yeah, technically you can do it.
Thank you.
Where was the next question?
Catch.
Yeah, so question about Cortex front-end and combination of Thanos. Last time I tried to do it, I believe a month ago, these implementations kind of killed all the replicas of my Thanos stores because of how Cortex front-end divides long-range query to day length. So, and basically query would hit raw data on the stores, which is much bigger load for this component. Are you saying that it's kind of fixed, or is there a workaround? Or
I can answer to that.
You go first.
Sure.
Well, I mean, I'll just say you can limit the parallelization in Cortex frontend as a flag.
And
So if you
also-
don't want to dispatch, 365 queries to your cluster, then you just set the flag to whatever the limit is. I think the default's quite low though, so I'm surprised you've done that.
No.
Oh, yeah, and you
so
can switch off the splitting as
You
well.
can switch the splitting as I kind of suggested to you like a month ago. But the key point is that Cortex doesn't have done something. It has other means to just improve this path. However, Thanos has. So we need to think about making sure Cortex, the front end, so the caching is kind of, I don't know, I hope you can allow the contributions for that. As we discussed, but yeah, essentially we need to make sure that when you query potentially down some data, you don't split by day, but split by other means and then cache in a different way. It's not straightforward, but definitely we need to make this path easy for Thanos users, right?
But for now, you can just disable
Splitting,
splitting, and that's it.
I would
okay.
say, yeah.
I think, I'm just trying to think like the splitting and the caching are quite heavily coupled, so you're probably better off limiting the parallelization.
Okay, thank you.
Just set it to 1, right, and it'll behave the same.
Hi, I have a question. How does alerting engine work with the Thanos or Cortex behind? Can we query and alert on all the like multiple clusters and so on?
Do you want to go first?
Yeah. So yes, that's a good question. Yeah, normally the topology is that you should keep your alerts locally to Prometheus, but you have a good point that okay, what about the global alerts? Let's say so alerts that use requires the global view essentially. And yeah, for this we have a special Thanos ruler component which does query alert and rule evaluations on top of query API, and Cortex is exactly the same thing. And I guess you can tell us more about other optimizations you made. For example, you use database for rules, or like you have large kind of many different types of rules. I heard about those.
Do we?
Yeah.
Okay.
Anyways,
I've not worked on the ruler. I've not worked on the ruler actually. Jacob in the back, he's the most recent one to have touched it. So he fixes the next lot of bugs. But no, we have a very similar story. We have a ruler component that you can run and it will evaluate rules. We have live data in the Cortex cluster, or relatively live data. So you could evaluate alerts there, but as Bartek said, like I wouldn't advise it. You should evaluate the alerts in the Prometheus, in my opinion. Yeah, I mean, Jacob can go into more. We've recently made it horizontally scalable. So you can run as many as you want and rules will be sharded out to individual rulers. Yeah, we can store the config. We have a config API, so you can load the config in via an API instead of config files. But I believe you can also use config files. And it's it's all the other stuff, multi-tenant, etc. But it's like in general, it's the same as the way Thanos does it. Uses the same code.
Hello. Regarding long-term storage, how long are you committed to be compatible with archived blocks?
That's a very good question. Yeah. So for the Cortex side, do you still have 3 years worth of data, Brian? Yes. So we started the project 3.5 years ago, and we've still got data from 3.5 years ago. We can only read 3 years apparently, but like I'd love to know why. But no, like we did deprecate a couple of schemas, but I believe that was not actually affecting backwards compatibility because you could always read via the old schema versions. Yeah, like long story. But yeah, no, I mean our plan is to always be able to read data. Basically, like as long as it doesn't become too much of a burden, and then we'll have to engage with the community and see. But we've got no plans to delete code which would stop us reading old data. How about you?
Yeah. For Thanos, we use the TSDB block format, so we're trying to be we're trying to use exactly the same tooling and even code in certain places as Prometheus does. And since TSDB format didn't change, we don't have that problem. But yes. This format is also versions, so I guess we could rely on this.
Yeah, we had to take a fork of PromQL for early versions for the old alert version, the old alert syntax, because we used to not use YAML before Prometheus 2.0. We used to use our own format. So we've actually still got the ability to read Prometheus 1.0 alert rules in Cortex, which I thought was interesting.
Yeah, that's a good point. We need to maintain that for the long-term storage to work. Right?
Good question.
So,
sorry.
In the very long run, will Cortex and Thanos become one?
I mean, maybe that's the implication. I don't know. It's not really up to me.
It's not up to me as well.
Yeah, like it depends.
I mean, it all depends on both communities and the collaborations that starts now. I think it's a very good step forward to this, and whatever will happen, let's see. But I really like that both projects can have benefits from joining forces on minor pieces here and there. Who knows how it will be in the future? Like we don't want to push anything.
Oh, we've tried many names.
Yeah, like let's skip it.
Yeah. Today I found some V1 rules sitting on my laptop. Apparently, I was testing something in 2017 and never deleted them. Next question.
Next to Cyril at the back.
Oh, actually, I'm not going to do that because I see where the camera is. I'll throw it in front of you.
Oh.
Yes, look at me.
It's not going to work.
Close. I have a question which is pointing into the way how long data can be stored, and also how can I migrate my old data, which is potentially also 3 years old or older, to Thanos if I want to go from a normal Prometheus setup to a Prometheus Thanos setup. So.
So if you use Prometheus right now, it's kind of straightforward. There's a hidden flag on sidecar that just uploads the compacted old data. So it should be straightforward. And the interesting part would be to know how to do it from other systems, but I guess we need some custom code for that. But yeah, from Thanos' perspective, it should be single flag.
Okay, that's quite it.
That was good for it.
Yeah. Needed another foot.
One in the far right over there.
Oh, yes, you're there, yep.
I have one question about the goal of a global overview. I think Cortex supports multi-tenancy in a way to limit read access to the data. And we are trying to get like a super user who can then read all data, but we can't make it work. Is it possible or not?
Yeah, it's a really good question. Can we have a super user access to all data? So the interesting thing about Cortex is nowhere is there actually like a list of users written down. Each request you send in has a user ID header basically that says what user it's for, and similarly queries that go in have the same user ID header. So it's relatively easy to write a query, to write code that would execute a query against all users that have written to the system recently. But the challenge would be historically, we'd need a second index basically for that. So that's really, I guess, the only thing that's stopping us do it right now. But again, not something I've been working on at all. Like I know something Brian over in the corner here has been pretty keen on, or was asked for in the past. And there's, I think there's a compromise we could find that would work quickly, and the longer term thing we could figure out. But yeah, no, not something you can do out of the box right now. Nice.
Time for another one or two.
Go on, Richie. Richie's got a question.
A question, not a statement.
So
That sounds like a statement.
Oh yes, it does. When will Thanos be just a build time option of the single binary Prometheus?
Let's see. Well, as the newly elected president of all things Prometheus, no, I mean, I don't know whether like longer term this would ever get merged into Prometheus. I don't think that makes a lot of sense, to be honest. And also like reusing the Prometheus code is super easy. It's got well defined, as the chap from Sysdig said, so really well defined interfaces. So there wouldn't even be much of a benefit from merging it into Prometheus. You're just trolling, are you? Okay, sorry.
I'd
will
love
not
to see
feed you
the sidecar.
So how many Romeo and Juliet references did I make you remove by my little intro?
I've never actually read Romeo and Juliet. So
terrible. You see, even I thought of et tu Bartek, then full Cortex. Same author. Any other questions?
Go on, stop asking questions.
Okay.
Just to go on, Ben.
Oh.
I was going to say, why not merge the sidecar, at least some of the sidecar components into Prometheus itself?
Yeah, I think that'd be a good idea. Like it's we merged remote write. I see no reason why we shouldn't merge
The shipper.
Well, actually, I'm thinking more the query interface. The gRPC query interface makes more sense to me. But yeah, the shipper as well. Why not?
So the gRPC interface is super similar right now. So technically, yeah, the kind of the shipping stuff would be interesting to consider. Yeah.
And that's another area we've been talking about collaborating on. Like we have a very similar interface inside Cortex for shipping chunks around on query time between ingesters and various other components. And if we unified on that, it would make kind of interoperability between the two systems pretty straightforward. I think we're done.
Okay, no more questions or trolling?
Thank you very much.
Right then, it's break time for half an hour, so be here again on the hour, and we'll start lightning talks on time.